Hello and welcome to this video. In this video, we are going to look into the topic indices. When you write a number using indices, you have written it in the index notation. Any number can be used as an index, including zero, negative integer, and fraction. The index tells you how many times the base has been multiplied by itself. For example, 3 multiplied by 3 multiplied by 3 multiplied by 3. This can be written as 3 power 4. Here the number 3 represents the base and 4 is known as the index. Okay. So a multiplied by a can be written as a square, a to the power 2. And a is the base and 2 is the index. So the index value, this can be a positive integer or a 0 or a negative integer or a fraction. Laws of indices. Law of indices are very important in algebra to quickly simplify expression and work with numericals and algebraic terms. There are 6 laws we need to know and understand. How to multiply and divide with indices, raising a power to another power and power of 0, negative indices and fractional indices. We will look at the different laws of indices. In this video, the first law is a power m multiplied by a power n equal to a power m plus n. So multiplying indices. What do you notice here? When we multiply indices, actually we are adding the powers. When you multiply index expression with the same base, you can add the indices. A power m multiplied by a power n equal to a power m plus n. For example, 2 power 2 multiplied by 2 power 3. This can be written as 2 times 2 multiplied by 3 times 2. This is equal to 5 times 2. Okay. By applying the law of indices, we can write this as when the bases are same, you can add the powers. 2 plus 3 is 2 power 5. Let's look at another example. 2x cube multiplied by 3x power 4. Okay. How to do this? First multiply the numbers. 2 multiplied by 3 is 6. 2 times 3, 6. Then apply the laws of indices. So the bases are same here. Then the power can be added. So the power is 3 plus 4, which gives 7. Okay. Let's do these examples. Simplify p square multiplied by p power 4. The bases are same. So add the powers. 2 plus 4 gives p power 6. And here 2x cube multiplied by 3x square. First multiply the numbers. 2 multiplied by 3 is 6 and x power is 3 plus 2, which is 5. Here we have 4 and here we have 1. So 4 multiplied by 1 is 4 and P power is 5 plus 2, 7. And what about Q? Q power 3. Then the next question is x cube multiplied by x power 6 equal to x power m. So let's solve the left hand side. X power, because the bases are same, the power can be added. 3 plus 6 is 9 equal to x power m. So when a power x equal to a power n, that is the bases are same, then the power can be equated. X equal to n. We are applying this law here. M is equal to 9. The next law of indices is about the division of indices. A power m divided by a power n equal to a power m minus n. Notice that we actually subtracted the powers here. But again, the important point to be noted here is that the bases must be same. Okay. So when the bases are same and it is in division, then we have to subtract the indices. For example, y power 5 divided by y cube. This can be written as y power 5 minus 3 is 2. Okay. Actually, y power 5 is nothing but y 5 times divided by y cube, that is y 3 times. Now we can cancel out these. So we get remaining y square. So here also y square. Let's look at another example. 32 g power 32 divided by 4 g power 4. When it has numerals, first simplify the numerals. 32 divided by 4 will give 8. And here both the numerator and denominator has the same base g. Okay. Then for division, we actually have to do subtraction. 32 minus 4, which is 28. Okay. First, you have to divide the numbers and then apply the law of indices for the division. Now let's do this question. Simplify m power 15 divided by m power 5. The bases are same. So subtract the powers. 15 minus 5 is 10. And here first divide the numerals. 8 divided by 4 is 2. Then the bases are same. Subtract the bases. 8 minus 4 is 4. And this one is a power 2 minus 6. So you are getting negative indices here. A power minus 4. The next question is 5 power n divided by 5 power 4. Can be written as 5 power n minus 4 equal to 5 power 6. Okay. Remember the law, a power x equal to a power n. When a power x equal to a power n, x is nothing but n. By applying that, when the bases are same, the power can be equated. So n minus 4 equal to 6. So by adding 4 on both the side, we get n is equal to 10. Then the third law is raising a power to another power. So a power m, the whole thing raised to the power n is equal to a power m multiplied by n. So in the power there is a multiplication. When powers are raised to a power, we multiply the powers. Okay. For example, a square the whole power 3. This can be written as a power 2 multiplied by 3, which is 6. Okay. Two a power 3 the whole power 2. Okay. First, let's do the number part. 2 power 2. Okay. So 2 power 2 is 4. Then a power 3 multiplied by 2, which is 6. Let's work out these examples. Simplify x cube the whole power 4, which is equal to x power 3 multiplied by 4 is 12. And what is this? The power actually is a fraction. 36 the whole power 1 over 2 is nothing but square root of 36, which is nothing but 6. X power 16 the whole power 1 over 2 is nothing but x power 16 multiplied by 1 over 2. 16 multiplied by 1 over 2, that is 16 multiplied by half gives 8. And here 256 power 1 over 8 and y power 256 multiplied by 1 over 8. 256 can be written as the power of 2 as 2 power 8. Y power 256 multiplied by 1 over 8. So this 8 and 8 gets cancelled and this gives 32. So which is equal to 2 y power 32. Okay. The fourth question is 3 power t is equal to, how to write this one? 3. If it is square root, we used to write 1 over 2. And here we have the number 5. So 1 over 5. Okay. So now the bases are same. So we can equate the powers. T is equal to 1 over 5. Next, raising a number to the power of 0. A power 0 is equal to 1. Any value to the power 0 is equal to 1. Okay. For example, x power 0 is 1. Okay. How we are getting this? Let's take x square divided by x square. So what we get? X power 2 minus 2, which is 0. Okay. So if we cancel these two, we get 1. Okay. What that means is x power 0 is 1. So the first question here is the value of 10 power 0 is what? 1. 7x power 0 is nothing but 7 multiplied by x power 0 is 1, which is 7. Then the third question is find the value of 3x power 0 when x is 5. So for whatever may be the value of x, the number power 0 gives always 1. So 3 multiplied by 5 power 0 equal to 3 multiplied by 1, which is 3. Next, fractional indices. A power 1 over m can be written as mth root of a. A power m divided by n equal to nth root of a power m. So this is a unit fraction. It gives the root, and this is the non-unit fraction. First you need to use the law of indices for raising a power to another power. Then you need to use the unit fraction. Let's consider this. How to write this one? So this represents the root. So a power 1 over 5. So already square is there. Okay. And by applying the laws of indices for raising a power to another power, actually we have to multiply the powers. So you get a power 2 over 5. Okay. Let's simplify this one. 5 root of a square is a power 2 over 5. And the power is 3 over 2. Now apply the law for raising a power to another power. That is, actually it's a multiplication in the multiplication of the indices. So a power 2 over 5 multiplied by 3 over 2. You get a power 3 over 5. Okay. Let's try these examples. 64 can be written as cube root of 64. This is 4 cube. Power 1 over 3. Apply the law of indices for the powers raising to the another power. It's actually a multiplication. So we get 4. Okay. Square root of 5 can be written as 5 power 1 over 2, the whole power 8. Now apply the law of indices for raising a power to another power. 5 power 1 over 2 multiplied by 8, which is nothing but 4. 5 power 4. And this, first apply the for the number 1 over 2 and x power 16 multiplied by 1 over 2. 36 power 1 over 2 is nothing but square root of 36, which is 6. X power 16 multiplied by 1 over 2 is nothing but x power 8. And here, first apply for the numbers 1 over 2, the whole power 3, multiplied by x power 2 over 3 multiplied by 3. So 3 and 3 gets cancelled. So what is 1 over 2, the whole power 3, which is nothing but 1 over 2 cube. 1 cube divided by 2 cube. 1 cube gives 1 and 2 cube is 8 multiplied by x square, or x square divided by 8. The next law is about the negative indices. A power minus m can be written as 1 over a power m. A power minus 2 can be written as 1 over a square. Let's solve this question. 5 power negative 4 can be written as 1 over 5 power 4. What is 5 power 4? 5 power 1 is 5, 5 power 2 is 25, 5 power 3 is 125, 5 power 4 is 625. So 1 over 625. And this can be written as 4 power negative 2 divided by x power negative 2, which is equal to 1 over 4 square. Okay. X power negative 2 can be written as x power 2. It will go to the numerator. So x square by 16. And 1 over 27 can be written as 2 3 cube, 1 over 3 cube power negative 2 over 3. Okay. When the number 3 power 3 goes to the numerator, you will get the power as 3 power negative 3. Now apply the law of indices of raising a power to another power. So it's nothing but the multiplication actually. Multiplying negative 3 by negative 2 over 3. This 3 and 3 gets cancelled. Negative 1 multiplied by negative 2 is nothing but 2, positive 2. So 3 square, which is 9. And this is 4. P power 5 multiplied by P power 2. Add the powers. 5 plus 2 is 7. Then Q power 3 and negative 4. So 3 minus 4 is negative 1. Okay. This can be written as 4 P power 7 divided by Q. I hope you found this video useful. Check out the description box for the other crash course video links and other past paper solution video links.